moving into a new unit, okay? And in this unit, we're going to be talking about different types of functions here. Now, we already talked about all the parent functions already, okay? You guys haven't forgotten those, right? How many parent functions are there?
8.
8, okay. Adriana, give me one.
Quadratic.
Quadratic, okay. Sean, give me another one. Anissa, give me another one. Donnie, give me another one. Zach, give me another one.
Grace
Yeah, don't be whispering to nobody. Chris, give me another one.
Square root.
Alicia, give me one. Absolute value, yep. And it's 1, 2, 3, 4, 5, 6, 7. I'm missing one. Who knows that last one's here? And it is reciprocal, yes. Okay, so you have all these, okay? And hopefully you haven't forgotten what they look like, correct? Okay, because realize that when we get more in depth into the different types of functions that we have, like your radical functions and your power functions, they're going to have some similar features as some of these functions that we already know. So if we ever forget, say for example, what like x to the 5th power looks like, okay? After today's lesson, you'll realize that it has the same features as a cubic function, okay? So these are still good to know because they're kind of like your base. So if you ever forget any of the other ones that we learned about, you always have these to reference, okay? So today, we're probably going to be able to get through graphing and analyzing power functions, and then we'll save radical functions and solving radical equations for tomorrow, okay? Just as a reminder, Wednesday is an early release day.
Wednesday?
Uh-huh. It is not an H2H lab day. So that means you have all your odds. Which means you have me.
I like a baby.
No!
You make sure you watch the video.
Wait, I gotta watch it.
So, here we go. A power function is any function that's in the form of f of x equals ax to the n, where a and n are non-zero, constant, real numbers. Now, a is a real number, n is a real number, such as 3x squared. 3 would be a, the squared, the 2 would be n, okay? Even your cubic function, your parent cubic function of x cubed, a would be what number? 1, and n would be what? 3. So your quadratics and your cubics are already power functions that you know of, okay? Now, a monomial function. Monomial means what? One term. One term functions like x squared or x cubed, okay? Or even f of x equals 2. These are examples of what types of functions that we talked about.
The paranormal.
Constant. Okay, f of x equals 2. It's the same thing as y equals 2, a horizontal line that crosses the y-axis in 2. So even your constant functions, and then of course, your power functions are examples of monomial functions. Just make sure that we clear that up. Okay? Monomial, 1. Power functions are basically one term, but to a particular exponent. Okay? Now, all your power functions are going to have similar features. Okay? So, if n is even and a is positive, and before I continue, I'm going through every part of this slide. So if you follow along with me and you're listening, you'll pick up on some other things that I might say that aren't in the slides, correct? You're following along with me, right? Cool deal. If n is even and a is positive, and prime example of that is x squared, which is what our graph looks like, correct? Now every power function where n is even and a is positive is going to have the similar features of a quadratic, okay? So if you ever forget that, like x to the 4th or x to the 6th, it's going to look similar to a quadratic, okay? And all of these features are going to be the same. The domain, negative infinity to positive infinity. The range, I start at 0 and it's all of my positive y values, so 0 to infinity, 0 is included. I have an x and y intercept of 0, 0. And if you notice, all quadratics are continuous functions, okay? What makes something not continuous? If I gotta pick up my pencil to continue drawing it, I have 3 different types of discontinuity, reviewing section 7. You're not writing because you're going to tell me the 3 discontinuities, right? Okay? Let me see. Alicia, give me one. Removable, also known as a whole. All right, Marshall. Jump, and the last one? Infinite, yes, okay? So with these particular functions, when n is even and a is positive, it continues all the way through. There are none of those 3 types of discontinuities. But don't worry, there will be some that will have those discontinuities. I have y-axis symmetry, okay? Which means that it's symmetric to the y-axis. I'll work for a second. I have a minimum at 0, 0. I am decreasing from negative infinity to 0. Remember, decreasing is when, if you were to trace over it, your pencil's going down. So from negative infinity to 0, I'm decreasing, and I'm increasing from 0 to infinity. And lastly, my end behavior, which I talked about in Unit 7. The limit as x approaches negative infinity. So as x approaches negative infinity, my y's are going to infinity. They're getting bigger. And as x approaches positive infinity, my y's are continuing to get going towards positive infinity. Now don't forget, this is left end and right end behavior, okay? So no matter what power function I give you, if a is positive and n is even, it'll have all those features. Okay? Does everybody understand that? Now if a is negative, it got flipped over the x-axis. Okay? So, if it got flipped over the x-axis, does that change my domain? No. My domain is still negative infinity to infinity. Does that change my range? Yes, it does. Okay? So when a is negative, but n is still even, my range is going to end up being what? Careful. It's going to be negative infinity to 0, because if it gets flipped over the x-axis, it now looks like this. So now it's all of my negative y values. So that's from negative infinity to 0. Okay? Does everybody understand that? So, plus you also have a graph right there too on your paper. I haven't flipped my slide yet, but follow along with me. I have an x and a y intercept at 0, 0. Okay? And I'm still continuous. Even if I got flipped over the x-axis, I'm still continuous. Okay? I still have y-axis symmetry. Okay? And this time, I don't have a minimum, but I have a maximum. Where's my maximum located? 0, 0. Okay, just like how my minimum in this case was located at 0, 0. When it opens down, there is a maximum this time. If it's flipped over, now we're down to our intervals. Am I increasing anywhere? From negative infinity to 0, because I'm going up from negative infinity to 0. So I'm increasing there. Am I decreasing anywhere? 0 to infinity. I am decreasing from 0 to infinity, okay? So increasing where? Negative infinity to 0 and decreasing from 0 to infinity. And what about my end behavior? Okay? What about my end behavior? Looking at the left end behavior. What's happening as x approaches negative infinity? What's happening to my y's?
Going negative.
Going towards negative infinity. Very good. And what about my limit as x approaches positive infinity? What's happening? So now you have all the features for when n is even and a is either positive or negative, okay? So no matter what, even without graphing, if I give you a monomial function, you'll be able to tell me all the information without even graphing it, okay? If n is odd, look at that picture. What does it look like? You've seen this before. Like a cubic, okay? You've seen cubics before. So all of your odd power functions are going to look like cubics, some variation of cubics. What's the domain here? Negative infinity to infinity. And your range? The exact same, okay? The exact same. Let's see. It does cross the x and y intercept. It's 0, 0. Is it continuous? For the whole thing or only for part? Are there any discontinuities? The whole thing. So it's continuous from
Negative infinity to infinity.
negative infinity to infinity. Or you could write it in set notation. How do you write that in set notation? X is the element of all real numbers. So it is continuous on the entire interval. Does it have any symmetry? Origin. Remember, odd functions have origin symmetry, okay? And what about extrema? What does extrema mean? Maxes and mins, okay? Does this have a max or a min? Say again? No, it does not. So what are you going to put down for extrema? There's none. There is no extrema with odd power functions. Is this decreasing anywhere? No, it's only increasing. Reading from left to right, I'm going up to draw the rest of that. So increasing from negative infinity to infinity. And you see your end behaviors are already written down there for you. Okay? Your left end behavior would be negative infinity, and your right end behavior would be positive infinity. All odd power ones look like this. If A is negative, what happens? It flips. Okay? The domain and range does not change though when it flips. When it flips, is it still continuous or not?
Yeah.
It is still continuous. On which interval? Is there any point where it has any breaks, gaps, holes? So negative infinity to infinity. Does this y-intercept or its x-intercept change? No, it doesn't. Okay, so that's still the same. What type of symmetry does it have? It still has origin symmetry, because just because it's flipped, that doesn't change. So far, when n is odd and either A is positive or negative, none of this information has changed so far. Okay? But there is a piece of information that does change. It's no longer increasing on the entire interval, it is now decreasing. Okay? Because I'm going down to trace over from left to right. Okay? I still don't have any extrema. And does my end behavior change?
Yes.
Yes, it does. As x approaches negative infinity, what does y approach? Positive infinity. And as x approaches positive infinity, y approaches
Negative.
negative infinity. So there's your end behavior. Questions? So no matter what power function I give you, you can tell me all of the good stuff, all the juice. Okay? All the juice. Let's look at the next one. The first example, actually. Okay? You don't need no calculators here either. This is simple. It's just 1/2 x to the 6. That is a 6. I don't know how good of copies they were, but it is a 6. So, A. Is A positive or negative? And N, is it even or odd?
Even.
Even. So if it's even and it's positive, it should be opening up. Okay? Let's go through all the good stuff. It's even, so my domain is what? Negative infinity to infinity. Okay? When n is even and a is positive, what's my range? And is 0 included? Sure is. Remember, and you can think, okay, let me think back to my classic parent quadratic. All of those features are going to be the same for this x to the 6th function, okay? What about my intercepts? 0, 0. In my end behavior, I use limit notation. Okay, you guys have plenty of space here. I'm kind of running out of mine, so mine's going to look really cramped, but you should have plenty of space. As x approaches positive infinity, what's going to be happening to my y's? They're approaching positive infinity. And as x approaches negative infinity, still going to positive infinity. What about continuity? It is continuous. And lastly, am I increasing anywhere? 0 to infinity. Am I decreasing anywhere? Negative infinity to 0. So without even looking at the graph, you can pull out all of this information because you know that n is even and a is positive. Okay? Yes?
Why would it 0 be in a bracket?
Because remember, with intervals, it doesn't matter whether or not that point is included or it's not included. Okay? Because it's basically going to be shared with another. If you look, 0 is shared between increasing and both decreasing. So it can be included that it's increasing up to that point. That's the turning point. So, only with brackets matter when we're doing domain and range. Now the easier part, graphing this. What do you think would be the best way to graph 1/2 x to the 6th? And note, you can't say use our calculator. I know my intercept is 0, 0, and it should point up. It should look like a quadratic. Okay? So let's get some more specific points. How do I find specific points on this curve? Make a table. Let's make a table. You guys have still enough space, right, to make a table sometime? Try to give y'all enough space. I don't have much. Please be careful with your tables and your graphing. The order of operation rules still apply. What are you going to do first? The exponent, and then whatever that number is, you're going to take half of it, multiply by 1/2. So what's negative 2 to the 6th power? No. You should be able to know your powers up through 7, pre-calculus people. So what's 2 times itself 6 times? It is 64. It is 64. So half of 64 is 32. And yes, it's a positive 32, okay? Think about it. You're multiplying a negative by itself an even number of times, so it's always going to turn positive. Negative 1 to the 6th power is 1 times by 1/2 is 0 to the 6th power times 1/2 is 1 to the 6th power 1/2 32, and then you have 32. So here are your points that make up this curve. Now realize you do not cross the line, the 2 line until 32. So when you draw your curve, I know you're going to be outside of your grid by the time you hit 32 on your Y. So you need to make sure you draw it as such.
I have a question.
Yes.
So in the equation,
Yep.
it's fx equals 1/2x, you know.
Yeah.
Couldn't we just already know that we were gonna put that first point at 1/2? Because I kind of figured that, but I mean I could have been wrong, but I wasn't. So
So are you saying is your first point always going to be at the A value? Is that what you're asking?
yeah, basically.
For your power functions, You can always say that, but once you start moving your power functions left, right, up, and down, that does change.
Okay.
So, do be aware of that. Other questions? Alright, so 4 minutes. You're working on the next one. Give me all the good stuff. Give me all the juice. And then graph it. Alright, so it's been about 4 minutes. And Bradley, give me one piece of information. Doesn't matter which piece, give me any piece of information that's going to answer any of these questions.
The domain,
Okay?
negative infinity, infinity.
Would you guys agree?
Yeah.
Very good. Okay, Jamie, give me another piece.
The range is -3.
Would you guys agree? Yes, because what is n? It's odd, right? What number is n? 5, and a is? It's negative, okay? So if you think back to when n is odd and a is negative, they have all the similar types of features, okay? JP, give me another piece of information. Doesn't matter, you don't have to go order, give me a piece.
Intercept is 0 with
The origin, good stuff, okay? And Steven, give me another piece. Doesn't matter. Any? So you're saying this one? The right, okay, so the right hand behavior is to negative infinity. You got 3. Good stuff. And Adriana, give me another piece. Doesn't have to be decreasing. It's decreasing from.
Negative.
Would you guys agree that it's decreasing on the entire interval? So if it's decreasing on the entire interval, is it ever increasing? Yeah. Okay, I got 2 more pieces of information to answer, okay? I got left in behavior and I got continuity, okay? So, Jazzy, give me a piece, give me either. Good stuff, and continuity. Shannon. Is continuous on what? So the whole thing, only half of it, up to a certain point, what? The whole thing, so that would be from, very good. So those are all your pieces of information. Did you guys get a chance to make your table? Okay, good. Now be careful here. You are raising each of these x's to the 5th power, and then whatever that number is, you're multiplying by a -1. So -2 to the 5th power is what number? It's -32. But then when you multiply by the -1, it is +32. So be very careful. Plus, you knew it should have went like this and like this, correct? So that's another good way to check yourself. When x is -1, what's y after you simplify? 1. When you plug in 0. When you plug in 1. When you plug in 2. So you had a cubic-ish looking function that shouldn't have crossed 2. So after you get past your outside your group. There you go. Questions. Pretty simple, correct? And again, if you can at least remember all your features about a quadratic or a cubic, you can answer any other power. Now, when x is less than 0, meaning it's like x to the -1 or x to the -2 or x to the -3, it will be undefined as 0. There will be some type of discontinuity. So, who remembers? When you have a negative exponent from algebra 2, who remembers when you have a negative exponent? It gets split. So this is the same thing as what? A reciprocal function, 1/x. Okay? X to the -2 will be what? Not 2/x. 1/x². So does everyone see y is undefined at 0? Because can you have 0 in the denominator? What type of discontinuity is there with zeros in the denominator? Say it. It's infinite discontinuity, okay? So when n is less than 0, you're going to have infinite discontinuities here, okay? Now, there's not a nice big old chart laid out and everything like that for you to figure out, okay, what's the domain when it's a negative even number? I mean, a negative even number or a negative positive number, okay? We're going to actually discover that ourselves by graphing the function first and then pulling out all the information, okay? So, 2x to the negative 4. How can I write that so that my exponent is not negative?
1 over 2x.
Careful. That negative 4 is only to the, so it's going to be 2 over.
Then you would put the 2 on the outside, and then after you find it,
Exactly. So only that x to the 4th goes down to the bottom, not the 2. Okay? Let's make our table. Still no calculator just yet. When I plug in negative 2, what's negative 2 to the 4th power? 16. So what's 2 divided by 16? What does that reduce down to be? What about what's negative 1 to the 4th? And what's 2 divided by 1? When I plug in 0, it's undefined. So there's an asymptote there. Remember, that's the type of discontinuity when you have 0 in the denominator. However, when I plug in when I plug 1 in for x, what's y going to be? 2. And when I plug 2 in for x, what's y going to be? So I have these points here. Do you have an idea of what this may look like? Like a trapezoid? Well, I can't cross over the y-axis.
Oh, it's gonna be
It's
I
gonna be that curvy
thought it was gonna be steps, but it's
No.
gonna be reciprocal. No.
It's gonna kind of have the branches of a reciprocal function, but it's not gonna be in opposite quadrants. It's gonna be side by side. Because think about it, the bigger that x gets, right? 3 to the 4th power is 81. 2 over 81 is a small number, like smaller than 1/8. When you plug in 4, 4 to the 4th power is 256. 2 over 256 is another really small number. So the bigger that x gets, what's happening to my y's? It's getting smaller to what number? 0.
But it never touches.
But it will never touch or cross that x-axis. What happens if it was a negative 3 or a negative 4 or a negative 5?
It's getting smaller.
Keeps getting smaller. Not to negative infinity, but just closer and closer to what number? 0. And if I plug in a fraction, what do you think? Well, let's see. Let's plug in 1/2. So that's 2 over 1/2 to the 4th power. What's 1/2 to the 4th power? 1 over 16. How do I simplify this?
Keep change.
Keep change flip. 32. So the smaller that x gets, the closer to the y you get, the bigger my y's get. So yes, draw a smooth curve here for your notes, you guys. But this is what even negative power functions look like. Okay. All right, this is what even negative power functions look like. Okay? The domain. Looking at this graph, you can figure out what it is, right? Say it again, Adrian.
All right.
Oh, I don't.
0.
So negative infinity to 0, 0 to positive infinity. What about your range?
0 to infinity.
Is 0 included this time like how it was in the other ones?
No.
No, it's not. So again, these are all the features of negative even powers. Okay? Intercepts.
There's none
And why aren't there any intercepts?
because of the
Because of the asymptotes. Not only is there a vertical asymptote, but there's also a horizontal one. Okay? Because it's getting closer to the x-axis, but it's not crossing it. Okay? What about my end behavior? What's my right in behavior? As x gets bigger, what's happening to my y's? To what number? What about my left end behavior? What's happening as x gets closer to negative infinity? What's happening to my y's? 0. Is it continuous? What type of discontinuity do I have? Infinite discontinuity. You guys will have enough space, correct? Is it increasing anywhere? From what to what? What's happening after 0? So there are all the features when n is a negative even number. Questions? What if a was negative? It would flip over the x-axis. So, if a, so in this case a is positive, if a was negative, it would be flipped over the x-axis. Would the domain change? What about the range? What would the range be if it was flipped over the x-axis? Negative infinity to 0. Would there be any intercepts? No. Would my end behavior change? So basically it would look like this. Would my end behavior change? No, it wouldn't. Do I still have infinite discontinuity? Yes. And my increasing and decreasing would basically switch. Okay? So realize that these just switch if a is less than 0, and this becomes negative infinity to 0. Okay? But everything else stays the same. You're going to do the next one on your own. Make a table, look at the graph, and then go from there. All right. Here's this one. When you made your table of values, did you use -2 and -1 and all that?
Yes, ma'am.
When you plugged in -2, what you get?
Negative 1/4.
And -1 and 0? Undefined, yes. There's again another asymptote because it's the same thing as saying 2 over x to the third. What happened when you plugged in 1? And 2? 1/4. So you basically had something like this. What did it look like? A reciprocal function. Because if you think about it, isn't a reciprocal function, doesn't it have an odd power in the denominator? So yes, all of your odd power, negative odd powers are going to look like your reciprocal functions, okay? So that means the domain and the range are all going to be the same as your reciprocal function, okay? Is it continuous? No, you had infinite discontinuity. Your end behavior as x approached infinity, your y's got close to 0. And as x approaches negative infinity, it got close to 0. Was I increasing anywhere? No, I was decreasing. And we do have to break that up because it's undefined at 0. We do have to break that up. Any intercepts? No, no intercepts, and the domain and range were the same. Negative infinity to 0 and 0 to infinity. I think that was all of it, right?